Our 4.4 notes are over sinusoidal function and mathematical models. Once again, this is the second portion of the one we did yesterday. What I want you to do is read over this and go ahead and highlight everything that is important, such as the time at t equals 0, that's our starting time. We indicate that the maximum number is 200 coyotes, and it occurs also at t equals 2.9 years. The next maximum is 800, and it occurs at t equals 5.9 years. From this information, you can start by graphing your sinusoidal function, knowing that you have your x coordinates here, you have your y coordinates. Your y coordinates represent the population or the number of coyotes, and your x coordinates represent your time. So let's label our coordinates and our axis. So I will say population here, or number of coyotes, and on this side I will call this time, and time here is expressed in years. Based on the information that you have here, at t equals 0, that's where it starts, but we don't know yet what is the population at t equals 0, but we know that we will have 200 coyotes at t equals 2.9. So if I call this point 2.9, I know we will have 200 coyotes, meaning a point here on your graph. And based on the information that you read also, this one, the lowest point is 200, and the highest point is 800. To know where your dotted line will be, it will be halfway between 200 and 800, and halfway between those two is your 500. Now, the next point on our x-axis is given because they say at t equals 5.9 years, we have 800. So at 5.9, let's label this as 5.9. We will have 800, which is our maximum point, or our maximum number of coyotes. If you keep the pattern, the next point will be here, and it will be about the distance between 2.9 and 5.9 is 3. So between 5.9 is the next point, it will be 3 as well, giving us 8.9. And that will be the next lowest point. From here, I can actually connect the points and get the shape of the graph, and it will look as follows. Now, how do I know the period and everything about this in order for me to write the equation? Our first equation is to sketch, the first question is to sketch the graph. The next one is to write the equation. Alright, the equation, of course, if you start with y equals, after y equals, my vertical shift is at 500, so I will write 500, and after 500, we're looking at the highest point. We can pick this point or the other point. Now, you get to pick which point you want to go by. So, if I want to go by this dark point or the black point I just put, I will have y equals also 500. And the green one that I wrote below here, or this, I will label it green. I'll pick this point. So one of them can be positive, the other one can be negative. It doesn't really matter. You know how to write the equations. So if I follow with the green one, I will have 500, and it will be a plus because I'm starting up. My amplitude here is 300. I don't know what B is yet, but I know that here, because I'm using the time, I will call it T. Now the green point that I have, I will write negative 5.9. All I need to do is figure out what B is. And to find B, the period is from 2.9 to 8.9, meaning 6. So period is equal to 6. So if I do 2 pi over 6 to find B, I will get pi over 3. So here, all I need to write is pi over 3. And if I was doing the black point, which is the one all the way down here, it would have been 500, this time minus 300, pi over 3. And inside the parenthesis, you will receive t minus 2.9. They're identical, these two equations. Now I will continue this problem using the green equation, which is this one. All right, the next question says, now we're trying to predict when the population will be at t equals 7 years. So t equals 7 years, all you have to do is plug this in your calculator and calculate it for 7 years. And if you do so, you will end up with the value of, I'm just doing it on my own calculator, and at t equals 7 years, I end up with 622 coyotes. So here you will have 622 coyotes. Coyotes are declared to be endangered species when their population drops below 300. Between what two non-negative value will be below 300? I will go ahead and erase this to write somewhere below it to answer this question here. What you got to do here is figure out when is it going to drop below 300. So put your equation on the calculator, graph the line y equals 300, and you will find out that it is between 2.097 and 3.703 years. Between those two, the population will drop below 300. Let's now work on the second problem. It's over the tsunami. Once again, I'm gonna let you read it by yourself, and all you have to do is, all I would do is actually highlight the most important stuff. The period is about 15 minutes. Period is 15 minutes. Suppose that a tsunami with an amplitude of 10 meters approached the river where the normal depth of the water is 9 meters. Assume the depth of the water varies sinusoidally with the time. Predict the depth of the water 2 minutes after the tsunami reached the pier. So all I know so far is that at t equals 0, I'm 9 meters. And at t equals 15, I have 10 meters. So I know that my full, actually 15 is 10 because the full period is from 0 to 15. So if I want to graph this, this is what I will do. I will first have my x-axis and my y-axis, and I know that at t equals 0, which is somewhere here, I'll put this one 9. This point is 9. Somewhere high up there, I don't know yet what it is, do I? 10 meters. So normal weight, 9 meters. The amplitude is 10 meters. So if you start at 9, from this one, the highest point will be at 19, and the lowest point will be at -1. Now I know that my full cycle will take about 2 periods. I mean, we go all the way till 15. So if I make my full cycle, knowing that it goes down first, I will have something like this. And that will be a full cycle. So at this full cycle, when it goes back to 9, I'll be at 15. If you find halfway between 0 and 15, it will give you the middle, meaning this point is at this point is at 7.5. Well, my graph is kind of funky, but halfway is at 7.5. This other point, which is the highest point, this one will be at 11.25. And the last point will be about 3.25. Now you have the full graph with all the critical points labeled. Of course, this is 0. Now, let me label my axis. This one represents the depth, and this is in meters, and this one represents your time, and that's in minutes. Alright, the first question says, predict the depth of the water 2 minutes after the tsunami reached the pier. What you can do is figure out the equation. To figure out the equation, I would say d is equal to, there are multiple ways of solving this. You pick. Since we know this point, I'll choose to pick this point, knowing that it will be amplitude 9. Actually, the amplitude is 10, but we start at 9. And I have 10 and I'm gonna use the sign because I'm picking this point. And because it's from there going down, I put negative. And inside, since it's not shifting left and right, I will just have t. However, I need to know what b is. To find b, I know the period is 15. I will do 2 pi over 15 would be my b, and I cannot simplify that, so I will leave it as 2 pi over 15. I believe this is the simplest way to find the equation, but you can go on and find the cosine equation, and that will be 9 plus 10 in case I use, know that my dotted line is somewhere here, and this one is a 9. 9 plus 10 cosine of the same 2 pi over 15, but inside the parenthesis I have t. I can use the 3.25 or I can use the 11.25. So let's pick this point, and I will say is t minus 3.25, and it's not going to be plus here because I'm picking a point below, so I will turn that plus into a minus, and that will give me a different equation. It's up to you which equation you want to use. I prefer you use the first equation and plug this into your calculator. If you plug into your calculator to predict the depth of the water 2 minutes after the tsunami, you should understand that is 1.569 meters. After 12, you should get 18.511 meters. Note that these two are on your table. According to the model, what will be the minimum depth of water? Well, the minimum would be at -1 meter. That's according to the model. But if you want to know exactly what it is, and it will just be 0 meter. 0 meter in real, of course, in real world. We cannot have a negative. In real life, it's 0 meter, but of course, according to the model, it will be a -1. Alright, she says always draw a graph and write an equation even the problem does not specifically ask you to do so. And you note that the first thing I did was I drew the graph and wrote the equation because it will help you figure everything else out.